In this video, we're going to look at how to calculate the discriminant of a quadratic and try and understand what it actually means. So a quadratic is an equation that can be represented by a parabola shape. And what we're going to do is we're just going to draw three different shapes here and look at three different features. I'm going to draw a parabola maybe looking a bit like this. I'm going to draw a parabola looking a bit like this. And I'm going to draw a parabola, for example, looking like this. Okay, so three different parabolas here. What we're going to do, actually I'm going to move this parabola up slightly. Yeah, that's better. So what we're going to do with each of these parabolas is we're going to look at the number of roots that each parabola has. Hopefully you can see that in the first diagram, the parabola has two roots, here and here. And you notice how those roots are different. What we're going to say in the language of when we're trying to communicate a discriminant is we're going to say there are two real and distinct roots. Distinct just means different. So there are two real and different roots. If we have a look at this parabola, not the best diagram, hopefully you can see there is only one root. And that root actually lies on the x-axis. We could have also had it coming like this, for example, and it would lie here. But when there's only one root and it lies on the x-axis, we would say there is one repeated root, because there's only one root here. And the root is technically repeated. I won't go into the video in this, and I won't go into the example here as to why it is, but we can see it in a later video. And if we have a look at this last parabola, obviously this would be continuing up a bit more, we can hopefully see that there are no roots. There is no point that this parabola crosses the x-axis. So we would say there are no real roots. So what we're going to do is we're going to be able to calculate the discriminant after seeing this video. And after we do that, based on our answer, we'll be able to classify that quadratic into one of these three categories. It has two real and distinct roots, there's one repeated root, or there's no roots. So how do we calculate the discriminant? To calculate the discriminant of an equation of the form ax squared plus bx plus c is equal to 0, that just means a general quadratic, we evaluate b squared minus 4ac. b squared minus 4ac is just a wee formula you will need to remember. It's not given to you in your formula list. What is given to you in your formula list is the quadratic equation. I'm just going to write down the quadratic equation here. You would use this if it asked you to solve an equation to, for example, 2 decimal places. And hopefully you see that as part of the quadratic equation that you are given, it technically has the discriminant calculation within there. You just need to be able to remember how to get there. Okay? So what we're going to do is we're going to extract the values of a, b, and c and slot them into this equation. And we're going to get a number out. With that number, or with our answer to that equation, it's going to fall into one of three categories. It's going to be bigger than 0, equal to 0, or less than 0. If our answer is bigger than 0, that would imply that there are two real roots. So if b squared minus 4ac is bigger than 0, there are two real and distinct roots. So that would fall into scenario 1 here. If our discriminant was equal to 0, that would say that there is one repeated root. That would be this guy here. And finally, if we worked out the discriminant and it was a negative number, that would imply that our parabola would not cross the x-axis, like this one here. Okay, so let's try and use this now and apply this in a few problems. So, determine the nature of the roots. So, the question here is asking us to determine the nature of the roots. It doesn't actually say calculate the discriminant. But see, when it says determine the nature of the roots, that's asking how many roots are there? Are there two roots? Is there one root, or are there no roots? So although it doesn't tell us to do this, when you see determine the nature of the roots, you should be thinking discriminant. Okay. Okay, that's a connection you need to be able to make there. So determine the nature of the roots of this equation. So we're going to need to evaluate b squared minus 4ac. So we need to extract the values of a, b and c. So a is 2, b is negative 5, c is negative 3. We'll slot these values in. That's going to be negative 5 squared subtract 4 times 2 times negative 3. That's going to give us 25 subtract 8 times minus 3 is minus 24. And that is going to be 49. Okay, so we've worked out our discriminant, we've got our number. So what category does that fall into? Well, it falls into this top category here. The discriminant is bigger than 0, so there are two real and distinct roots. So I actually need to write that. I need to write since b squared minus 4ac is bigger than 0, there are two real and distinct roots. And that's us finished the question. So when it asks us to determine the nature of the roots, this is really what it's getting at. This is us here, what I've highlighted here, this is us determining the nature of the roots, this is us telling how many roots there are. But in order to do that, we had to work out the discriminant. So what could this graph look like? It might look something like this, for example, because it's got two real and different roots. Okay. Example 2. Last one. Calculate the discriminant and determine the nature of the roots. Well, this one's really told, like, kind of walked us through here. It's told us exactly what we need to do. So we want to calculate the discriminant. So it's b squared minus 4ac. We've got a is 2, b is minus 12, c is minus 18. So we'll substitute these values into our equation. Minus 12 squared, subtract 4 times 2 times, actually I want to make that plus 18, I meant to change that, I want to make that plus 18. There we go. So it's 2x squared minus 12x plus 18, so a is 2, b is minus 12 and c is 18. So minus 12 squared minus 4 times 2 times 18. So that's going to be 144 subtract, and I think this is going to be 144. And when we figure that out, we get 0. So in this instance, we've worked out the discriminant, and the answer is 0. So what category does that fall into? Because we've calculated the discriminant here, we now need to determine the nature of the roots. So we're going to say, since b squared minus 4ac equals 0, what are we going to say? There is one repeated root. There is one repeated root. So this is us here determining the nature of the roots. That's us done it there. So that's us finished the question. What might this look like? Well, it's going to be a parabola that has one root that lies on the x-axis. So it might look something like this, for example, where the root is on the x-axis. Okay, so you need to be able to recall like these three scenarios here, 1, 2, 3, with that kind of exact wording. The SQ are quite particular with it. Okay, so that is how we calculate the discriminant, and doing that allows us to determine the nature of the roots. Thank you very much.